Okay, so we're looking at the challenge question from Minitest week 30. So we've got this kinetic sculpture, and it's all just suspended, and they're telling us that it's in equilibrium and the rods are horizontal. So I'm going to look at this rod first, so this bit hanging off the end of the right-hand side. So I'm just going to focus on that. So I've got these three, a rough sketch, these three masses, and then they're hanging from there. So I'm going to call that P, and I'm going to take moments about P. So I'm going to call the three masses A, B, and C. And one thing they tell me in the question is that, where did it say it? The distances between the points marked on each rod are equal. So each of these divisions are the same. So I'm going to call those X. So that distance is X, that distance is X, and that distance is X. Okay, so I'm going to take moments about P. And that is in equilibrium. So I've got the mass A is going to be pulling down on the left-hand side. So that's going to be trying to turn that rod anti-clockwise. So that's going to have a moment of AG, because A is the mass, so you need to times it by G, and that's 2x away from P. Then I've also got mass B hanging down on the left-hand side. So that's also going to be trying to turn that rod anti-clockwise. So that is going to be B times G, and that is X away from P. So don't forget, moment is just the force times the distance. And then I've got, I'm hanging off the other end, mass C, which is going to be trying to turn, well, causing a clockwise moment, and the whole thing's in equilibrium, so they must equal each other. So that's going to be CG, and that is also a distance X away from P. Okay, so I can cancel through by G and X. So actually, if you forgot G, you would get, you could still get the correct answer, but just not quite from the correct method. So then I've just got 2a plus b equals c. So I've got an equation with three unknowns, so that's not going to be solvable, but I do know there's only 5 possible options for a, b, and c. So I could start to think about the possible combinations. So they're 1, 2, 3, 4, 5. Clearly, a can't be 3, 4, 5, because then 2a would be 6, 8, 10. I don't have a value big enough for c. So I can say that, so if A is 1, for example, then that's going to be 2, and then it could be 2 plus 2 is 4. So that would be A is 1, B is 2, C is 4. Or it could also be 2 plus 3 is 5. So that would be A is 1, B is 3, C is 5. I think A could also be 2. So if A was 2, 2A would be 4, yeah, and I could do 4 plus 1 equals 5. And actually, I think, if we can't get this working, I might have to revisit that, but I think they're the only possible combinations for A, B, and C. So I'm definitely using the 1 kilogram weight there somewhere, and then the others, I can't say. So just from looking at that rod, I can't say for certain what A, B, and C are. Okay, but we'll come back to that. So let's now think about moments for the whole structure. So now I'm sort of sketching this rod here. So I've got those two masses, and again, all of these divisions are equal distances. And then what I'm going to do for this is, when I'm looking at the bit hanging off here, I'm just going to combine this as one single mass, because that's what's pulling down on the top rod, just the total mass of this part of the structure. So just to sort of show it's a combined one, I'll just draw it. I was going to say a slightly bigger rectangle. No, it's nothing like a rectangle. So whilst I'm at it, that one's a bit of a state as well, isn't it? Right. Okay, so let's call these, so I've used A, B, and C, so let's call these D, E, and then I'll call this one F for now, but obviously that's A, B, and C combined. And again, all of these divisions are the same, so let's call those X. Okay, and then let's call that point R. We've used P already. Okay, so let's take moments about R. So I've got mass D causing an anti-clockwise moment, and that's a distance of 3x away. I've got mass E also causing an anti-clockwise moment, so that is x away. And then I've got this mass F, which is actually A, B, and C added together, is causing a clockwise moment, which is keeping it in equilibrium, and that is distance of 2x away. So again, I can cancel through by G and by X, which leaves me with 3D plus E equals 2F. Okay, so now I just need to check which of these three options for A, B, and C can work. So I'm just going to check them in order. So A is 1, B is 2, C is 4. So that would mean the total mass of this bit here is 7 kilograms combined. So that would mean that F was 7. So let's just check that. And also, so if F is 7, and then also which two weights or which two masses have I not used? So looking here, I haven't used 3 and 5. So let's see if we can get that working. So if F is 7, that's going to equal 14. If D is 5, that's going to become 15 plus 3, so that doesn't work. If D is 3, that becomes 9 plus 5, which I think does work. So we could obviously just double check the answers. I think the way they phrased it, they haven't implied there's more than one option. So the other thing I could do is just double check that neither of these possibilities do work, because I was only expecting one. So it seems as though I've just got lucky and got there straight away. So let's then sketch out what we're saying for the final answer. So what did the original sculpture look like? Okay, so that was, I was calling that one D, and I'm saying I think that D is 3 kilograms. Then I was calling that one E, and I'm saying I think E is 5 kilograms. Then there's the support there, and then this bit hanging off the end. Okay, so then the next one along was C, which I'm saying is 4. No, sorry, what am I talking about? The next one was A. So 1, 2, 4. So I'm saying, make this a little bit bigger. Okay, so I'm saying 1 kilogram, 2 kilograms, and 4 kilograms. Oh, you can't see that at all. Okay, so that's me putting all my values back in. So I could do another check and see if it's all in equilibrium. I'm going to be lazier than that and check the solutions. 3, 5, 1, 2, 4. Yeah, that is what we ended up with. Interesting question, that one.